our development and build environment, and Haskell, which is the language in which we will develop the application. In terms of prerequisites, I expect you to have a basic understanding of Haskell, but that's about it. There will be nothing advanced, no type-level programming or anything of the like. It is just functions and I/O actions. So we will be building a temperature converter. That's a simple application, but it will showcase several GTK plus widgets. So as you can see, there are input fields, there are labels, there is a button, and there is interactivity so that the application reacts to users' input immediately. When they so we are converting between degrees Celsius and degrees Fahrenheit, and we do it without any additional button press or something like that. Just as the user is typing in some textual value, it is passed as a number and converted into another temperature scale. The button here is supposedly getting the weather from some server, but in reality, instead of doing a network request for this demo application, it just waits 3 seconds and gives us a random number. The purpose of this button is to demonstrate how to offload work to other threads, because if something takes 3 seconds, you definitely don't want to do it in your UI thread, because it will make your application unresponsive and the operating system will actually ask the user if they want to stop the process. So these are the components that we will be going over today. Now, we start with preparing a build environment. And it's not as easy a task as you might have expected, because it involves using a system library. Typically, when developing in Haskell, we can get by using Haskell-only libraries. But when it comes to GUI development, there are no major GUI frameworks implemented purely in Haskell. So we must deal with system dependencies. And at the moment, I happen to be using Mac OS, and on Mac OS there is a popular package manager called Brew. So I decided to install GTK Plus using Brew. What could possibly go wrong? Turns out a lot. So at first, actually, it does install GTK Plus successfully, and we can start looking for Haskell bindings to GTK Plus. And I can't recommend enough GI/GTK. It's great because it's mostly auto-generated, so it's always up to date. There was the previous there was another binding library to GTK called GTK2HS, which also worked quite nicely, but it was mostly handwritten, so there were a lot of functions and widgets missing there. GI/GTK is almost always up to date, and the few issues that I had with it, I reported and got an answer the next day, and the fix the same week. So it's well maintained and really a nice library. So we'll be using that. Now that I have the system library and I've selected my Haskell bindings to it, I may want to build a small Cabal project. And as you can see, Cabal will offer to install Haskell GI. That's the library that generates the bindings. And then the bindings themselves are split into many smaller libraries: GI JLib, Cairo, GObject, GIO, GDK, and GTK. So we will be using the entire family of libraries to create our application. But even though it starts well, soon we see an error, and it arises due to a version incompatibility. You see, when I used brew to install my system library, it installed version 3.24.23, which I can check using the package config utility. Now, the problem with brew is that it doesn't let us downgrade. It doesn't let us select a particular version. It just tries to install the latest and greatest, which of course could work if not for the fact that in new versions, sometimes compatibility breaks, and it takes a while to get the bindings updated, even if they're auto-generated. Sometimes we need to update the generator itself if the format has changed, and that doesn't happen immediately. But we wouldn't want our build process to be dependent on synchronization of such events. We don't want to wait for the stars to align until we can build our application. So what we are going to be using instead is Nix. And Nix is great because it gives you a lot of control. You can write a declarative configuration file, and it will be reliable and reproducible. Always the same versions, no matter the system on which you run it, no matter the condition or time of the day, you will get reproducible results on that machine. And it handles system libraries and Haskell libraries. So if we need the versions of the libraries to be compatible, we just use Nix, and it gets us, and we select a snapshot of Nix packages where these libraries play nicely. So that's not the only way, of course. You can prefer other ways to manage your dependencies, but Nix works really great for me, so that's what I personally recommend. Now, to use Nix in your project, you start by creating a file called default Nix. And this file contains the configuration for building your project. And this configuration is written in the Nix language. So Nix at this point is quite an overloaded term. It's the name of a language. It's a name of a package manager. And there is also NixOS, an operating system. So to be clear, we are not using the operating system here. We are just using the package manager, which can be installed on Ubuntu, other Linux distributions, and even on Mac OS. And to configure our project to use this package manager, we will be writing a configuration in the Nix language. So in the Nix language, like in Haskell, there are let bindings. And we start by binding two values. Firstly, Nix packages pin. That is a selection of a particular snapshot of Nix packages. So Nix packages is a repository that contains configurations of other packages, not the one that we are building, but the one that we are going to depend on, including the system and Haskell libraries. And we select a particular snapshot by specifying what you see here, omitted. Here goes the commit. So I found some commit that I liked, for which a binary cache was also available, so I don't have to build too much on my system. I specified it here, and then I also specify the hash, because the hash allows Nix to avoid re-downloading the thing repeatedly. And then I bind a variable called packages by importing the Nix packages pin selected above. So I'll be making use of this packages variable when describing the configuration for my project. And as long as I use it, I will have a predictable, specific choice of dependencies, dependency versions. Now, I continue my configuration by calling the make derivation method. And essentially, it means that here I'm going to describe how my application should be built. So I give the name for the application. I say where the sources are located. And since I put my default Nix configuration in the same directory where I have my Haskell sources, it's just the current directory. It could be some other directory, of course. And here, omitted, we have build inputs. That will be a list of dependencies required for our project, which in our case is GTK3, the system library written in C. That's package config, which I sometimes use to check what versions of packages I end up with. And of course, we will need GHC, a compiler to build our Haskell code. And when selecting GHC, I also list the Haskell packages, which I will be using. In this case, GI, GTK is the bindings I prefer. And there is also some miscellaneous additional configuration, which I will not get into. But I typically just copy it from project to project. Essentially, it instructs, this line instructs the linker how to operate within an Nix shell, and this line fixes a problem with locales. So it's boring and technical, and I just copy it without thinking too much about it. Now, here is our configuration file. It's just 30 lines of Nix code. We can enter a Nix shell. That's basically bash with all the environment variables and paths set in such a way that we have the required dependencies in scope. And here are the commands that I use to build my code. So I don't even need Cabal here because Nix brought all the dependencies into the GHC's package database. So I just call GHC and it already has the dependencies. I just tell it that my code is in the main.hs file, where to put the build artifacts, where to put the executable. I tell it to use the threaded runtime because I will be writing a multi-threaded application. I tell it to enable all the warnings, that's wall and optimizations. So this is the command that I will be using to produce the binary. On the other hand, to get fast feedback, just to see what type errors I have in my Haskell file, I prefer GHCID. That's a little nice tool which runs GHCI for you and repeatedly reloads your module as soon as you save it. So you have your editor open, you modify something, you save it, and then you immediately see the type errors, if any. Quite handy during development. So with everything set up to actually start writing code, let's see how we can recreate the user interface I've shown you using GTK+. The first thing you might want to start with would be creating a window. But if you just call the window new method and try to show the window to the user, GTK+ will swiftly remind you that it is a C library and greet you with a segfault. So before we create a window, we actually need to do some initialization. And to initialize GTK, we need to create a so-called GTK application using the application new method. And to the application new method, we pass the string with the name of our application. In my case, it's IO Serokell GUI Haskell app. In your application, of course, it will be a different string. And GTK application can handle initialization. It can handle uniqueness so that the user doesn't run two instances of your application. It can handle session management, desktop shell integration, and so on. But in our small demo, I will be using it just for initialization. So now that I've created an application object, I can use the onApplicationActivate method. And to this method, I pass an IO action called appActivate defined below. That's just an IO action, but what's important about it is that by connecting it to the activate signal, GTK calls events signals, by connecting to this signal, we guarantee that this IO action will be run after the initialization is complete. So inside this callback, it is indeed safe to create a window, and it is safe to show that window to the user. And this is our first checkpoint. By entering the Nix shell, building our application, and in the application, building the application object, creating the window within the callback, that is what we get, an empty window with no title. Not much, but it doesn't segfault, so that's something. And it's actually not that hard to give the name to the window. We call the setWindowTitle method. To do that, who would have guessed that it's called like that? So with that done, we can start adding some widgets into the window. Of course, I would like to start with something interactive and create my first entry. That's the input field. I create it with the entry new method, and I use container add to put this newly created entry into the window. And I also must call widget show again. So I call it for the entry and for the window, because in GTK Plus, every newly created widget is hidden by default. So even if you add it to a container, you must separately call the widget show method to make it visible to the user. And since I'm writing a temperature converter, I actually need two entry fields. So I factor out the logic to create the entry, add it to the container, and show it into a separate helper function, which I call add entry here. And I call it twice. So it will create the first entry, add it to the window, create the second entry, add it to the window, and we should see two entries, except we don't. We see just one entry and a warning. The warning is telling us that GTK application window can only contain one widget. But that is actually pretty reasonable. The window will not take care of the layout, because maybe you want to compose these widgets vertically, maybe you want to compose them horizontally, maybe you want some sort of tabs between your switch, who knows? So the window doesn't try to do that, and you must actually use a layouting object to get this behavior from GTK. And one of the simplest layouting methods is a box, which just puts one widget next to the other without too much complicated logic. And since I want my entry fields to be positioned vertically, one below another, I choose GTK orientation vertical. The number 10 tells it to use a space of 2 units between the widgets, and the set widget margin tells GTK that I also want 10 pixels around the box to space it out away from the window borders. Then I add this box to the window such that the window has just the box, and I add entries not to the window, but to the box. So I have this nested hierarchy now. The window contains the box and the box contains the entries. The box takes care of positioning the entries within it, and the window just displays the singular widget which it has inside. But now you will see this little problem if you try to resize the resulting application. Of course, the entries can stretch horizontally, but they cannot stretch vertically. That would, first of all, look awful, and second of all, be useless. So right now, it just fills the remainder of the window with empty space. It doesn't look particularly good either. So I think in this case, in case of this application, the simplest thing to do is to disallow resizing. So now I'm going to call the set window resizable method and set this property to false. And I also set the default width for the window to 300 units. So you can start seeing a pattern here. I call 3 methods, and all of them start with set window. And indeed, there is a pattern. So in GTK, there are certain naming conventions. To create a new thing, you write the name of the thing and use the word new in the end, such that, for example, we have application new, application window new, and entry new. To set some property, you write the word set, then the name of the widget or the name of the interface, in this case, it's window, then the name of the property, title, resizable, default width, or something else. So that's how we can configure, how we can create and configure our widgets. And you will find a lot of such methods and properties in the API reference. So let's continue and add labels to our entries, because we know that it's degrees Celsius and degrees Fahrenheit, but the user doesn't until we tell them. So let's tell them. And we tell them by creating labels which simply display some text. And I'm going to need a separate label for each widget. So when I create the entry widget, I use the add entry method. And to this method, I'm going to pass the label which will be next to the entry. And when I create the entry, I start by creating a box because I want my entry to be on the left and my label for the entry to be on the right. So I will put them into a box with orientation horizontal and 5 units of space between the widgets. Then I create the entry using entry new. I create the label using label new. I add the entry to the box, the label to the box, and the box to the outer container. I show all of them, and this is what I get, the picture on the left. So there is one minor problem here, is that the entry is exactly half of the available space, and the label takes the other half of the available space. What we want instead is for the label to be as wide as its contents, but for the entry to stretch and fill the available space. So we set the expand property to true for the entry, and this gets us the picture on the right. You can also see that I set the x-align property to 1. This aligns the text within the entry. So that 32 there, you can see that in one picture it's left aligned, in the other picture it's right aligned. So left aligned is 0, right aligned is 1, in the middle would be 0.5, and you can actually specify any floating point number there, for example, 0.8, that's slightly to the right. I guess somebody might need that. I don't see a good use for that, but the facilities are there. So we've got a window. In the window, we've got a box. In the box, we've got more boxes. In each of the inner boxes, we've got an entry and a label. So the last thing that is missing is the button. I created using, guess what? Button new. So after I created it, I set some properties, such as the label property, the h-align property, and then I add it to the vertical box and show it to the user. The button label property is, of course, the text that will be shown to the user in the button. And the h-align property actually tells the outer box how to position the button within the available space. So that's the next checkpoint. Now we've got an application. It's got all the widgets that we wanted. The widgets have reasonable layout. The properties are all set, and we can get to the next step, which is to make this application actually do something useful. For some definition of useful, of course. So that's application logic and behavior. We've already connected to one signal, which was called application activate, but there are plenty of other signals. For example, the editable changed signal is emitted every time the text within an entry is modified. So we can make our application do some interesting computation by attaching a callback to that signal. So I call the onEditable changed method. I pass the entry C to it. That's the entry that contains degrees Celsius. And in the callback, I specify what to do when the text within that entry changes. Of course, we start by getting that text. We want to know it changed to what? It's changed to some string S. And then just to demonstrate how it works, I'm reversing this string and putting it into the entry with degrees Fahrenheit. That's entry set text. So we have entry get text, entry set text. Quite straightforward, actually. So to do it, the actual temperature conversions, we are going to need a few more domain-specific functions. These are not GTK plus specific. These are just for the demo. And here they are. C to F and F to C convert temperature degrees from one scale to another. Parse double takes a string and tries to recognize a floating point number in decimal notation in that string. And if it's not a number, it gives you nothing. Render double is the opposite. It converts a floating point number into the decimal representation. And in this case, I chose to always render 2 digits of precision after the decimal point. And then we've got the get weather, the network request, which waits 3 seconds and gives you a random number, but it's probably as accurate as your average weather forecast. So when we are writing the callback attached to the degrees Celsius, first it gets the text, then it tries to parse it, and what should we do if it's not a valid number? What if the user wrote hello? Well, let's just not do anything. You might try to do something smart like validation, like highlighting your entry field red. That is entirely possible, but in this example, I'm not going to get into that. However, if we do get a valid number, we convert it using the C2F function. We render it into another string and set it to another label. And this actually implements the main functionality of our application. But of course, we want to do conversions in both directions. What if the user wants to convert Fahrenheit to Celsius? So I factor out the code that contains the callback into a separate helper, which I call set entry relation. It will have the entry source into which the user is typing. It will contain the conversion function and entry target in which the result of conversion must be shown. And I set the entry relation between the entries in one direction, C to F, and the other direction, F to C. But once I've done that, I start seeing some pretty weird behavior. So the user enters one digit, for example, 9, and it gets and they get 3 digits. So instead of 9, they get either 9.00 or even 8.42. What's up with that? Well, the callback is triggered not only by user's action, but also by programmatically triggered events. So when the user writes the digit 9 in the Celsius field, it is converted to degrees Fahrenheit, which triggers the opposite callback of converting from Fahrenheit to Celsius, then back and forth and back and forth and back and forth until it reaches a fixed point. So that's definitely not the user experience that we are looking for. Input fields behaving chaotically with these feedback loops and not actually giving accurate results due to rounding errors. But fixing it is not that difficult. Fortunately, we just need to add one check, which is to see whether the target entry is focused. So if the user has focused on the entry target, it means they have the cursor in this entry. They are typing in something. So the principle is simple. Don't mess with the user. Don't mess with the string they are typing in. So if the target widget is focused, don't do anything. But if it's not focused, do what we've discussed previously. And this gives us a nice bidirectional converter, which immediately shows the results to the user and doesn't interfere with their input. No feedback loops, and dare I say, a nice user experience. Now, for the last part of our application, we will make our button do something. And if we simply call the getWeather method, it will make the application unresponsive because it takes 3 seconds to produce the results. And during these 3 seconds, the application will not handle users' actions. If they try to press some other button, if they try to select a field, if they try to type something in, the application will not react. And as I also mentioned, the operating system will detect that the application is unresponsive, and it will helpfully offer the user to kill that application. We don't want our application to be killed, so let's not do that. Let's do something else. Let's do the work in a worker thread. Let's fork a thread using fork.io. But if you just fork a thread, you will be swiftly reminded that GTK is a C library. So you will see some errors. The application quit unexpectedly, assertions violated. What is going on? So the one rule of GTK is that you don't touch anything outside the main thread. So once you've done fork.io, you must be very careful not to call GTK methods, not to access data within GTK widgets. What you must do instead is to add another IO callback to the queue using the idle add function. So there is a queue of things to be executed by the main GTK thread, and you can add tasks to it. You can prioritize these tasks. And in this particular case, what I've got here is that I fork a worker thread. The worker thread does the network request, or just waits 3 seconds. This does not interfere with the user interface. But then when it's finished, when it's got the results, it adds another callback to the queue, and this callback will set the text using GTK entry set text. It is now within this callback safe to work with GTK widgets. And while all of this is happening, when it starts, I'm going to make the button unclickable so that the user doesn't click on it the second time on accident or on purpose to break our application. Oh my God, users are like that. So the button will be unclickable. And when we have indeed acquired our weather forecast, we will put the temperature back and make the button clickable again. And this is how it's going to work. The user presses the button and the UI is still responsive. We can select other fields. We can type something in, but when the task is complete, it will overwrite the contents with the data. And during the work, you can see the button is grayed out. The user cannot press it another time. And this is our toy application. It is now complete. So I'm going to talk about documentation and resources to write your own application, perhaps more useful and fun than what I've got here. But first, you may want to look at this application anyway to see how it was built step by step. I've got this repository, Serokell /GUI Haskell app. And the commits in this repository roughly correspond to the way this application evolved in the slides. So if you missed anything, if you'd like to look at it in greater detail on the next setup, on making the initialization work, making the layout, fixing the segfaults, and adding application logic, that's the repository you might be interested in looking at. Next, there is the API reference for GTK3 itself, the C library. Since the Haskell bindings are generated automatically, you will find most of the same methods and signals and interfaces that you have in the C library. You will also find them in the bindings. So the C reference is immensely useful. And of course, there are other examples of GTK plus applications written in Haskell in the Haskell GI repository. That's the repository for the bindings. So in their examples folder, plenty of useful examples that you may want to study. And on Hackage, you can look at the documentation for this family of libraries, GI, GTK, GDK, glib, and GI base. And the most useful part is often the index, where you can search for methods with roughly the names you expect. So if you are doing something with the entry, you may search for methods containing the word entry in it, such as onEntry activate, onEntry backspace, and so on. You will find them in the index for the bindings. And this is all I wanted to talk about today. If you have any questions, I will happily answer them. And thank you for joining me.
I think there were some questions in the chat. I'm not sure which of those were answered, but there were definitely some that were unanswered.
Okay, there is a question about a thread-safe API for writing applications like that. Maybe it exists, but I am unaware of such an API. There were discussions about using the void function. I just tried to avoid using too many functions in this talk, preferring to use facilities built into the language. So I wouldn't get the opposite questions about what is void? Oh, it's a monadic method. Anyway, you can use void, of course, if you prefer. Same goes for overloaded strings. You can enable them, but you can also just call text back explicitly. And not using Cabal. Oh, yes, I was very happy when I realized I can avoid a two-layer build system. So previously I used Cabal within Nix until I realized that I don't actually need to do that. Is there a Git repository to follow along? Oh yes, I've shown it in one of the last slides. And a question, have I used these GTK plus bindings to build a bigger GUI app? Actually, no. Yes, I started building a bigger app, but I did not finish, so I don't know if it counts, but I have used quite a few more widgets, if that's what you're asking, and they all work fine. I also used it for an application where most of the job was drawing. So I created a window and I just called Cairo methods. That's a vector graphics library just to draw on the screen, which also worked pretty well and it was quite efficient. So GTK comes with two libraries. They are, you can say they are tightly coupled. Although the developers pretend that they are not coupled, they usually go together. That's Cairo and Pango. So Cairo is the vector graphics library, which is used to draw all these widgets, and you can draw at top of them. You can draw lines, squares, ellipses, curves, and so on. And there's the Pango library, which does text layouting. So you can do fancier stuff with text, including Unicode bidirectional layout and stuff like that. It uses Harfbuzz as its backend. So it gets most of the stuff correct. And have I considered using GI GTK declarative? I have considered it, but I decided to stick to the basics. If you know the basics, then I think it's well, I wouldn't use a wrapper like GI GTK declarative if I didn't know what it used underneath, but that's just me. You may prefer to jump right into it and use the abstractions built on top without getting to the bottom of the abstraction lasagna. Where is Senti defined? It's defined in data.fixed. It's in the base package, and you can see all the imports in the repository I have shown. So you might want to look at that. You mentioned you wrote a GUI where you were drawing stuff. What exactly did you use to achieve that? Which lib? I used Cairo. So on Hackage, you will find bindings to Cairo, and it's well integrated with GTK. So there is the draw signal. You connect to it. I'm sorry, it's CAIRO, like the Egyptian city. Yes, and it gives you arbitrary precision, so you can scale your drawing. You can apply an arbitrary transformation matrix to rotate, enlarge, translate, and so on. And you can use primitives like lines, circles, ellipses, and I'm using it to develop a small toy project of mine. I'm trying to make a structure editor. If you're making something that doesn't quite fit into the widget model, that might be an interesting thing to look into. And you can either draw straight into the window, or you can use the existing widgets to create menus, buttons, and so on, and create a small drawing area within it. It's up to you. Might be outside the scope of this, but if not, how do you find the Nix packages commits that have binaries? By chance and by blind luck. What about stuff like localization? Well, I haven't looked into that, but I'm sure there should be some facilities for localization there. Just haven't personally looked into it. Are there any libraries for 3D graphics? Well, I think there are. They should be, but I haven't used them, so I cannot recommend anything. Do you use NIV for Nix pinning? No, I just use that small Nix expression that I have shown by manually writing the URL of the Nix packages commit on GitHub. Do you just handcraft the GUI GTK code in detail immediately, or do you use some high-level description? So I just write it by hand, but there is a thing called Glade to build your interfaces. So you can use this Glade thing, typing it into the chat, Glade, Glade, and it will give you an XML file. You can load this XML file, and it will give you the interface that you have designed. This way you can offload your design work to some other person who might not be so technically savvy, but have their ways with interfaces. The reason I prefer to do it programmatically is that it gives me better control. I can, for example, factor out something repetitive into a loop. If I need to create 10 identical widgets, I just write a method that creates the widget and do it several times. In the UI builder, I think you have to do it by hand. I might be wrong about that because there was some other issues with it. I've tried to use it, what was it, 5 years ago, I think, and it was just awfully slow. It didn't work all that well for me. But maybe they fixed it. Maybe it works well now. You might want to try it. All right. So it seems that there are no more questions. Aside from this new one. So is it possible to use an SDL2 surface with GTK? It might be. Tell me if you find out. Yes, it may be possible, maybe not possible. I haven't tried it. Who put on this talk? Is there a group I can follow or a blog you have? Well, I represent my company in this talk, Serokell, but I don't know if we have anything else in this direction that is just my personal experience of GTK that I wanted to share with everyone. Okay, thank you again for joining me today. And I guess if you get more questions that I didn't answer now, just ask them in Twitter and I will try to respond there. Thank you very much. Goodbye.